It's Saturday, getting a little coding done until the pre-workout starts to make my face tingle. I tried getting a little bit of coding done earlier this morning, but I couldn't do it because one of the packages that I use in Python wasn't communicating to the other package well enough. I guess I had a very limited version of it, very limited version of SciPy and NumPy, so I had to reinstall that the right way and go through all of this trouble just so that I could import Bessel functions. The reason I needed to do that is because I've been calculating Bessel functions by hand for L equals 0, 1, and 2. And by hand I mean I've defined a function for each of those different Bessel functions, as well as Newman functions. But what I'd like to do is just be able to loop over as many different Bessel functions as I want, instead of having to define one each time I increase angular momentum by 1. Meaning, in my code, I've been defining functions for J0, J1, J2, etc., and the same thing for Y0, Y1, and Y2. But what I'd like to do, and what I just did, was learn how to define it this way. The whole reason I need to do all of this is because my project isn't calculating wave shifts. My project is calculating triple differential cross sections. And hold on. This is the expression I have for the phase shift for a given L, for a given angular momentum quantum number. And here it says that it's in terms of the Bessel function of the first kind and of the second kind for a given L. So what I did to test this was I calculated this phase shift for L equals 0, L equals 1, and L equals 2. This also meant solving the Schrodinger equation for 3 different L. Only problem is that 3 different L is kind of an arbitrary number, and more than likely I'm going to need quite a few more. The reason for this is because this is the expression for the total differential cross section. And we're summing from L equals 0 to infinity. And this is in terms of delta sub L. This is in terms of the phase shift. Now ideally I won't actually need infinite terms in order for this to converge to the answer, but it's probably not going to just be 3 terms, which is why I needed to be able to generalize the Bessel function and Newman function to any, I guess, order that I wanted, instead of just having to continuously define this stuff. So it's just, now that my code is starting to work, which is exciting, I need it to start being more efficient. I have no idea how well this shows up on the camera, but what I was just doing now was making sure that the Bessel functions that I'm calculating versus the Bessel functions that I am importing from just some library that Python has, I wanted to make sure that we're calculating the same things. So one is a solid blue line and one is a dashed red line, and they're in perfect agreement. So that means that I can just use the imported library from now on, and I don't have to use my defined functions. Andrew, why don't you just import the libraries from the start? Well, I like to do it myself for the first couple cases just so I can appreciate being able to import a library later. It doesn't help if you have no idea what it's doing. I've also rewritten my code in terms of arrays instead of lists, which has just sped up everything. It's awesome. And it was actually someone who commented on one of my videos who suggested using arrays for, I think it might have been the video where I was just showing how to take derivatives in Python, and that gave me the idea to try to use that in my actual senior thesis. So in a sense, you guys helped me. As much fun as this is, I can't spend too much time on thesis stuff today because I do have a programming project due tomorrow, and I have a quantum mechanics midterm on Thursday. So it's Saturday right now, which gives me 5 days, 6 days, 5 days until my quantum midterm. That's plenty of time. If I can get some studying for that done today, and then some of my code for my project done today, then I can finish that tomorrow. Yeah, we got this. By the way, I had to watch a video on how to reinstall NumPy and SciPy in a way that would let me use Bessel functions and things like that. And I'm going to leave a link to the video that I used in the description, so that if anyone is interested in either just installing Python or being able to do what I do with the math and stuff like that, all the information you should need in order to install the necessary libraries will be in the description. My exam on Thursday is on multi-particle systems and variational methods, so I'm probably going to spend the day going over chapter 5 and 7 of Griffiths. I don't think I'll get through all of it today because I also want to spend a lot of time on my programming project because I severely underestimated how much time it was going to take me for the last one. That's the thing that's going to require more time, is this little project that I haven't really even looked at yet. I also need to take some time to start writing my senior thesis a little bit. Just getting, my professor wants me to start adding things to the appendix. So things like deriving the Numeroff method, deriving the method that I've been using to actually solve a differential equation, and also an appendix part that just goes over the special cases that I've been solving to verify that my code works. I also need to start thinking about how to explain the physics of what's going on with my senior thesis. So I'm getting pretty deep into the math associated with it, but I need to make sure that in the introduction and stuff that I have something to explain and I know physically what's going on. So I'll probably spend some time today just thinking about that. I don't know what else I'll be doing today, and I don't think it would be particularly interesting to just be showing me studying again. So I might end the video here. It seems like this is the time where professors are making sure to fit in one last exam and one last project before finals start. Let me know in the comment section if you've had this experience as well. Are you guys cramming for one last final, one last project or paper or things like that? Let me know in the comments. I'll see you guys there.